Hello everybody, my name is Muhammad Alvin Shahrin. I am one of the authors of this research. Other authors include Mrs. Arini and Mr. Husni. First of all, thank you for giving me the opportunity to present this research. Our research is parking application using dual layer geofencing, circle and polygon, and activity recognition at UIN Syarif Hidayatullah, Jakarta. Our research is motivated by the absence of available parking information, which make it difficult to find an available parking location. Then it also caused campus residents to park carelessly. The purpose of this study are as follows. The first is to implement geofencing and activity recognition to identify park users. Second is to implement circular geofence as notification area and polygon geofences as parking areas. And the third, knowing the accuracy of the combination of geofencing and activity recognition in detecting users who park at UIN Syarif Hidayatullah. The scope of problem of this research are as follows. Uh, Case study, the research was conducted at UIN Syarif Hidayatullah, uh, and geofencing that we use is Google's geofencing API. And geofencing that used were circular, sorry, circular geofencing and polygon geofencing. And activity recognition that we use is Google's activity recognition API. And then user activities detected in this study were on foot and in vehicle activity. And system development method that we use is RAD. And then users were assumed to have installed the application and had internet connection and have given permission to the application to access the location. There are two users in this application, namely admin and user. This application generated information about whether there were parking space available in the existing parking area and how many slots are there. And last, the application has not been integrated with the entrance portal. Our research flow can be seen in the following figure. We divide this research process into three major processes: problem analysis process, system design, and system implementation. Sorry. Uh, After the three processes are complete, in the end, we can draw conclusion about this research. The application that we design has the following architecture: Android as client and PHP as server. Both communicate via JSON format REST API. Okay, after this introduction, let me explain a little about geofencing. Geofencing is a technology that defines a virtual boundary around a real geographic area. As we can see in the picture on the side, mm, there are blue and orange circles on a map. The circles are geofencing, which indicates an area within a circular boundary. And the rectangle one is geofencing 2, but this is a polygon geofencing. The second technology that we use is activity recognition. Activity recognition is a feature of the location API owned by Google Play Services, which can notify the latest types of activities carried out by smartphone users. There are 4 activities that can be detected by this API. Sorry, there are 7 activities that can be detected by this API. The first is in vehicle, on bicycle, on foot, running, still tilting, and unknown activities. The proposed scheme for recognizing parking activity is as follows. User enter notification area. Number 2, user enter parking area. Number 3, user exit parking area. Number 4, user exit notification area. The successful parking conditions are as follows. When the user enters the notification area while driving, the user will get a notification and asked to enter a number plate if he wants to park. As we can see in this picture, uh, the circular blue is a notification area. This is a circular geofencing, the first layer of geofencing that we use. And then uh, the rectangle one is UIN Syarif Hidayatullah. The rectangle was described uh, the UIN Syarif Hidayatullah real geographic area. And the parking area was rectangle in this picture is a polygon geofencing. If we still drive the vehicle and enter the parking area, then the system will temporarily save the parking area. And then when he leaves the parking area on foot, it is considered as successful parking. The finished parking condition has the following state. When the user sorry, when the user enters the parking area on foot after previously successful parking, the user is in a pre-release parking state. And if he exits the parking lot while driving, then the user is identified as finished parking. And when he leaves the notification area, he will get notification that he just exit the campus. We also test the accuracy of the technology used previously in this research. Activity recognition accuracy testing. There were two activities to be recognized in determining the accuracy of this method in order to meet the need for detecting user movement when parking the vehicle. The first is driving activity and on-foot activity. Driving activity tested with two conditions. Number A, the result of detection when the user drives on vehicle and put the smartphone in his trouser pocket. There are 19 of 20 records accordingly with the expected. The percentage of success detection was 95%. Sorry, the log, as can you see, there was one fail detection, and that is tilting activity. Activity recognition testing, the second. Number B is the result of detection when the user drives a vehicle and put the smartphone in the back. There are 15 of 20 results accordingly with the expected. The percentage of success detection was 75%. Walking or on-foot activity uh, has that, that has tested with two conditions too. Number A, there are 7 of 20 detection results that do not match the result of detection when user drive on vehicle and put the smartphone in his trouser pocket. The percentage of success detection was 65%. Number B, there was 5 of 80 incorrect detection results when the user was on foot and using smartphone simultaneously. The percentage of success detection was 72.22%. And then geofencing has been tested. Geofencing accuracy has been tested with two conditions. Uh, how many distance was needed to detect user entered notification area and exit the notification area. Number one, enter notification area. The average distance required to detect a user entering the notification area was 12 meters from the given boundary. After five, after 5 tries, we have uh, we get the distance average is 12 meters. Number two, the average distance required to detect user exit the parking area was 14.2 meters from the geofence boundary. And then we also test the combination of activity recognition and that geofencing for parking detection. The successful parking was detected 70% parking success, with the average distance required to be detected was 8.71 meters. The tested parking area was the parking area in front of the Student Center building at UIN Syarif Hidayatullah, Jakarta. After going through this research, we get the following conclusion. The first is the application was able to detect the driver who parked without physical sensor in the parking area. Then, the system had two levels of geofence. Level 1 was the circle geofence as the area where the user will get parking info notification. And level 2 was the polygon geofence as boundary of the parking area, which is within the geofence level 1. Sorry. This was implemented when the admin determines the boundaries for the parking area. Accuracy of activity recognition in detecting user who was on foot and put the smartphone in a pocket reached 65%. And when the user was on foot using the smartphone reached 72.22%. For geofencing accuracy, the enter notification area event required 12 meters in average to be detected, and an exit notification area event required 14.2 meters in average to be detected. And for the detection of parking success was detected 70%, with the average distance required was 8.71 meters. Accuracy of the build system depends on the weather and connectivity of the user's smartphones. Okay, this is the last slide of my presentation. For your attention and time, thank you.